All right, this section is going to cover arithmetic series. What an arithmetic series is it is a sequence, it's an arithmetic sequence of numbers that are added together. And the sum of an arithmetic series is going to be given by this notation right here. Now, this notation has some different parts to it. First thing is this letter here is the Greek letter sigma, and in math, sigma always means sum. And you can think sigma starts with an S, and it is S in the Greek alphabet, and that S represents a sum. And the other parts to this, this value right here, K, is called the index. It does not have to be the letter K. Sometimes it's I or N, or just depends upon what the problem indicates. But this is called your index. 1 is the starting value that you are going to be plugging in, and then N, which is going to be a number up here. This number will represent the last value that you are going to put into the formula. And you'll put every integer in between here and here. And more specifically, besides integers, be every whole number between here and here. All right, so if we start with 1 and we plug 1 in for the K, what that's going to give us then is a sub 1. That's our first term. Plus, because this means sum, this means we are adding together the terms where we start with K is 1 and we end with K equaling N. So this would equal a sub 1, and then you'd plug in a 2, which would be plus a sub 2. Then you plug in a 3, which would be a sub 3, and then a 4, which would be plus a sub 4. And you keep on going until you reach this upper number, so it'll be plus and then a bunch of terms, however many terms are indicated in here. And then a sub n would be the last term in this series. Now, this is what your sum means. This is just a notation. This is what it actually means. It means we are adding together all these terms right here. Now, it is always much easier to use a formula for finding the sum than it is to actually add all these numbers together, especially if the series is a very long series. It's easier to have a formula for finding the sum, and that's what this formula is. This is n, which will represent the number of terms in our series, a sub 1, which is the first term in the series, and then a sub n, which is the last term in the series. S sub n, this simply means this equals the sum of the n terms. So if we had 15 terms, this would be S sub 15. All right, so n is the number of terms in your series. A sub 1 is your first term. A sub n is the last term. And remember that we can also find a sub n using our arithmetic sequence formula for finding an nth term. And then a sub k is this part right here. A sub k is usually going to be a formula, and that is going to be the formula for finding the value of every term in that series. All right, so let's actually work the problem. In this problem, let's go ahead and identify a few things here. Our index is n. 3 is our starting value. And then 8 is our ending value. So if we were to write out this series, and this right here, this represents a sub n. This is the formula that you would use for finding the value of every term in this series. So let's actually write out the series. So for this series, you're going to start out by substituting the first value, starting value. You plug this into n. That would give you 15 minus 3 times 3, and that's 15 minus 9, which is 6. Plus, because this is a sum, all right, so the next value after 3 is 4. So now we plug in a 4. So 15 minus 3 times 4 would be 15 minus 12, which is 3. All right, so the next thing you do is you plug in a 5, because we did 3 and 4. The next number is 5. Plugging in a 5 is going to give us 0. Then we're going to plug in 6, which will give you negative 3. Then we'll plug in 7, which is negative 6. And then we plug in 8, which is going to give us negative 9. So what we have done is we plugged in 3, 4, 5, 6, 7, and then 8 was the last number that we plug into this formula right here. So what this does is it gives us each term. A sub 1 is 6, a sub 2 is 3, a sub 3 is 0, a sub 4 is negative 3, and so on. So now you actually find the sum by adding these things together. Well, this is fairly easy to add together because you have a 6 here and a negative 6 here. Those will cancel out. You have a 3 and a negative 3. Those will cancel out. You got a 0, and then you have a negative 9. So this sum is actually just negative 9. That is the sum of this particular series. Now, even though this series was easy just to simply add up all these numbers, most series are not going to be like that. Most series, you're going to have a lot of numbers in here to add up, or you might have a bunch of fractions or decimals or something like that, so that it's not going to be all that easy just to add a few terms together. And so that's why we want a formula for finding whatever this sum is going to be. And remember that formula is n times a sub 1 plus a sub n divided by 2. And in this particular situation, we had 6 terms. And so our n value is going to be 6. Now, look at these two numbers and see how we get 6 out of that. If you subtract these two numbers, you end up with 5. You then have to add 1 to that, and that gives you how many terms there are. Because if you start with 3rd, 4th, 5th, 6th, 7th, 8th term, that totals 6 terms, because this is actually your first term in this problem. All right, so remember to subtract these two numbers and then add 1 to that. That gives you the n value. All right, so we have an n value of 6. A sub 1 is our first term, which was 6. A sub n was the last term, which was negative 9, and then divided by 2. All right, so this gives us 6 times negative 3 over 2, which is negative 18 over 2, or negative 9. All right, so that's how the formula works on that. All right, take a second to look at this problem, and I want you to write out the problem, write out the series, what plus what plus what plus what, write out your series, find the sum, And then I want you to use the formula for finding the sum as well. All right, I want you to go ahead and pause the video and do those two things, and then unpause the video and you can see what the result is. Okay, welcome back. Starting value, when you plug 2 in, you end up with 4 times 2 is 8, plus 1 is 9. And then the next number you plug in is 3, so that would give you 12, plus 1 is 13. And you keep on doing that until you get to 6, and 6 will be the last number you plug in, which gives you 25. Adding these values together, you get 85. All right, so using our formula, the number of terms we get by subtracting, so 6 minus 2 is 4, but then you add 1 to that, which gives us 5. Our first term was 9, our last term was 25, and dividing by 2 ends up with 85 as well. All right, so let's look at the next problem. It says, what is the sum of the first 10 terms of the series given by a sub 1 is negative 14 and a sub 10 is 40? All right, so we just want to know, what are all these terms going to add up to? All right, so if we use our formula, the sum of the 10 terms will be equal to n, which is the number of terms, 10 in this case, times the first term, which is negative 14, plus the last term, which is the 10th term in this problem, that's 40, and then dividing this value by 2. So this one is going to work out nice. All we have all the numbers that we needed for it. Negative 14 plus 40 is 26, divided by 2 is 13, and then multiplying you get 130. I hope you can see that this is much easier to use this formula than it is to try to find all 10 terms and then try to add them all together. It's much easier to use this formula right here. All right, take a second to write this problem down, and then I want you to work this out, and then I want you to pause the video right now, and then come back in just a few minutes after you work this problem out. Okay, so on this problem, we had this series right here, which starts with n equals 5, going up to n equals 19, which means a sub 5, since this is your first value that you plug in, a sub 5 is the first term in this series. And a sub 5 is 14, so that goes here. This is the last number you plug in for n, which means a sub 19 is the last term in this series. And if you take 19 minus 5, that's 14, add 1 to that, that's 15, which is the number of terms in this series. So using our formula, n times a sub 1 plus a sub n divided by 2, we end up with 420 as our sum. All right, so this question is asking us, what are the first 3 terms of the arithmetic series if the first term of the series is 19, the last term is 243, and the sum is 279. So let's think about what we are given right here. We know that the first term of this series is 19, and then we're going to be adding a bunch of terms together. We do not know how many, and then we know the last term of this series is 43. What we do not know is how many terms there are. All right, so let's go back to what this question is asking. What are the first 3 terms? Well, if we know the first term and we're trying to find the second term, what we need to know is what is the difference between the terms. All right, so if we need to know the difference between the terms, that would be called our common difference, which is D. Now, the formula we're working with in this section is S sub n equals n times a sub 1 plus a sub n divided by 2. Now, the problem with this formula for this particular problem is that there's no d in this formula. And what we need to do is find d so that we can get the next term in this series. All right, so where do we get d? We get d from the arithmetic sequence formula, which was a sub n equals a sub 1 plus n minus 1 times d. All right, so d is our unknown. That's what we are going to be finding here. All right, so a sub 1, that's our first term. We know that one is 19. A sub n, that's our last term, which we know is 43. However, what we do not know is how many terms we have. We don't know what n is. And in order to find d, we need to know how many terms there are. All right, so we need to know how many terms are in between here and here. Well, what we're going to do is we're going to come back to this formula over here to find out that n value. All right, so we do know the sum. That sum is 279. N is what we're looking for. The first term is 19. The last term we know is 43. Divided by 2. We can work this out. 19 plus 43 is 62. 62 divided by 2 is 31 times the n value there. Now if we divide by 31, that's going to give us 9. We can now take this 9 and plug it in for n. All right, so that's going to give us 43 equals 19 plus 9 minus 1 times d. Now, this 9 also means that this 43 right here, our last term, is a sub 9. That's our 9th term, is 43. All right, so working this out, we get 43 equals 19 plus 8d. Subtracting 19 from 43 is 24, which means d is equal to 3. All right, well, now we know that our difference is 3. That makes the next term in our series here 19 plus 3, or 22. And the next term would be 22 plus 3, which is 25. All right, so those are our first 3 terms of this series. Now notice we did not use just the sum formula. We had to use the arithmetic sequence formula from the previous section as well. All right, so what I want you to do is go ahead and take a second to write this particular problem down and then work it, and then unpause the video and see how your answer matches up with the one I've written down here. So go ahead and pause the video at this time. Okay, welcome back. So just like we did before, we took the sum, negative 231, set that equal to the information that we knew, the first and last terms, divided by 2, but we found out what n is, which is 11, and we substitute that into this formula over here because what our ultimate goal was to find out what the difference between the terms is, d, and plugging everything into our formula, we ended up with d is negative 3. And so that tells us that if we started with a first term of negative 6, subtract 3 from that gives us negative 9 for our second term, negative 12 for our third term, and that would continue on for a total of 11 terms, and then your 11th term would be negative 36.